The science news today is about me, but it's not just me. It's about an amazing group of kids I'm a part of. We are sending experiments into space on a NASA rocket and balloon.
Supernova Style Science News with Julie Seven Sage.
In this news segment, I'm going to actually show you the experiments that we are sending up and explain why they are important. But first, I need to tell you about this group I am a part of called the Clay Center Amateur Radio Club at Dexter Southfield School in Brookline, Massachusetts, where I am right now. It is the largest student-led ham radio group in New England, and it's open to everyone, even people outside of the school. How nice and awesome of Dexter Southfield to do that. Guys, most Tuesday nights they have a public observing night with their 25-inch telescope. The radio club also meets on Tuesday. It's a gigantic beacon for intelligent kids in the Boston area. It is in this club that I got involved in the Cubes in Space program with other kids. It is how we are sending experiments into space. The academic advisor of the radio club asked for a person to be the student lead and organizer for the group that would participate in the Cubes in Space program. And of course, I volunteered, and everyone agreed for me to be the lead and organizer for the group. It was a really big honor, but it was also a lot of work. My job was to stay in contact with the members of the club to see how their projects were going and to make sure everyone's experiments got done because I wanted everyone's experiments to get launched. Now, what is the Cubes in Space program? The idea is that students ages 11 to 18 years old design experiments, write scientific proposals for their experiments, and then submit them to be possibly accepted to go on a NASA sounding rocket or high-altitude balloon. The program is run by a company called iDoodle Learning. This is just one of many programs that they do to get kids interested in science activities. And not only do they have programs like this, they also create software to help kids learn. A 4-centimeter cube so that iDoodle and NASA can fit as many experiments as possible, but have enough space to have super cool experiments. There are other rules as well, such as no liquids and no explosives, which I would imagine they would not want explosives on a NASA rocket or balloon because NASA would probably not like the experiments to accidentally blow up. All the rules are there to make sure that nothing goes wrong and it doesn't mess up someone else's experiment. After experiments are approved, the students then have to build the experiments and send them in time for them to be launched into the stratosphere. My group submitted 6 proposals and all 6 got accepted, what I am so amazed at. 2 of them are getting launched up on the rocket, and the other 4 are going up on the balloon. I'm lead on 1, co-lead on 3, and a member on 2. The way we set it up was that the lead of the project was the person that created the initial idea and wrote the proposal. The co-lead was the person or people that helped with the design and write the proposal, and then everybody else who worked on the project are members of the team. My main experiment, the one I'm lead on, is testing the difference between metal foam and metal sheet of the same material, in this case aluminum, in the extreme conditions of the upper atmosphere. I wanted to use composite metal foam, but I did a segment on it a while ago, but we weren't able to get it because we couldn't reach the creators, and we didn't find a mass distributor, so I couldn't use it in my experiment. So instead we got the next best thing, smart metal, from a company called Isotech in Pennsylvania, who were nice enough to give us free samples. And so, of course, I'm going to share my data with them. What a great company. And this foam is so amazing. I'm looking at the absorbed and secondary radiation difference between aluminum metal foam and solid aluminum. The reason why this experiment is so important is that it can change how spacecrafts are designed and produced. Recently, metal foam has been looked at for use in spacecrafts. It is already being used in military vehicles. If I find that one of the materials is absorbing and letting off more radiation, then that might mean that that material is more dangerous than the other material for humans, for things like re-entry of the rockets for the workers on the ground. I am also going to test how the radiation will affect the strength of the metal by using compression. The ideal result of this experiment is that the metal foam is better than the solid metal because the metal foam has been proven to be better in other aspects than solid metal. All the other experiments in my group are also very important. Let me explain them. First is the Wash Cube by Jason and Conrad. It's testing the time difference based off acceleration. And yes, it is Guardians of the Galaxy. I think it's pretty funny. Next is the Solder Cube by Rafe, Hardy, and Morgan. It's testing the distortion of the solder based off of radiation. Next is the Fabric Cube by Jason. I'm co-lead on this project. It's testing different common fabrics to see what people could wear in space tourism, like silk, cotton, polyester, and even Kevlar. Next is the Computer Cube by my friend Nathan. I'm also co-lead on this project too. It's testing the data rate of the single-board computer based off acceleration and radiation. Other groups around the world are also doing very important research too. One group is setting up the smallest pacemaker to see if the space environment affects the way it works. And another group from India is testing a carbon fiber 3D printed structure that has a single-board computer inside. Both are amazing, and I would love to see those results. But what is so cool about cubes in space is that there are other experiments going up that have Brazil nuts and gallium. Even Ecuador is getting 5 experiments set up. This is something anyone can do if you have a good idea. On June 22nd is the launch of the sounding rocket from NASA Wallops in Virginia as part of the Rocket Fest 2017 week, where thousands of students from middle school to college will be there. All the participants of Cubes in Space will be able to go down and watch the launch and even present to everyone else about their project. My family is flying down because it is so cool. This program is so awesome. 2017 is the 5th year of Cubes in Space, and they will be doing it again next year. I totally recommend for you guys to join in because it is super fun, and you get to launch something you designed and built into space. You don't get to do that every day, and it's free to send your experiment into space. Also, you guys should come down to the Clay Center if you're ever in the Boston area on a Tuesday night if it is open. And you too can get to look through the 25-inch telescope that has even done experiments with the ISS. This place is so amazing, and so many smart people work and go here. The Clay Center is a real entertaining but informational place that is almost like my second home. I'll link the website for Cubes in Space below for you guys to read up on it and hopefully get involved. Share some science with your friends. Follow us on Twitter at supernova_style. Don't forget to press that subscribe button and show your supernova style.